Let's create a snake game in WPF using MVVM. To start off, open Visual Studio, create a new project, select C# WPF application. Let's name our project Snake Game. Choose a preferred directory and click Next. In the right tab, right-click on the project and click on Manage NuGet Packages. Search for Galasoft, click on MVVM Lite Libraries and click Install. Click OK to accept new changes to your solution. Accept the license agreement. Because we're going to be coding using the MVVM architecture, let's create a few folders in our project. We'll name the folders View Model, Models, and Messages. I like the side-by-side view when writing my XAML code. Let's change the size of our main window to 400 by 300 pixels. And let's change the window title to Snake Game. Let's add a keyDone property and assign it to an event handler. We'll call the event handler window_keyPressed, meaning whenever a key is pressed on the keyboard, this event handler will execute. In the main grid, let's create a row definition, and we will create two rows, giving the first row a height of 300 pixels. Let's then add a canvas to the first row and give it a black background. Let's add a content presenter to the canvas and bind the content property to an object which we will call GameField. GameField is an object that we will declare in the main view model. More on this a bit later. The design of our user interface is now complete. Right-click on the Messages folder, click Add Class, name the class Close Main Window Message. This is a message that will be sent before the game terminates. Make the Close Main Window Message class a message base. For this to work, you must include Galasoft MVVM Lite.messaging. Right-click on the message folder again and add another class. Let's call this class keyPressedMessage, which is a message that will be sent when a key is pressed on the keyboard. Make this class a message base. Add a public member of type keyEventArguments. The keyEventArguments contains information regarding which key on the keyboard was pressed. Right-click on the View Model folder and add a class. Name the class MainViewModel. In the MainViewModel, create an object of type Canvas and name it GameField. Create a constructor and give GameField a new instance. Let's go back to our main window XAML code and look at the code behind it. In the main window constructor, assign its data content to new MainViewModel. By doing this, our main window XAML code will be able to bind to objects that are declared in the MainViewModel. Next, we must register to the Close Main Window message. Notice the name Close Main Window. This is a function that we will create shortly. By including this function, we are informing the compiler that when a close window message is sent, this function Close Main Window must execute. And now let's create this function. The function must receive an argument of type Close Main Window message, and all the function does is close the main window. Next, we'll create an event handler and name it window_keyPressed. As I've mentioned earlier, this event handler executes when a key is pressed on the keyboard. And by the way, I just realized that I made a typing mistake. Notice I named it window_keyPressed with a capital P, but when I was creating the XAML code, I gave it a small letter P. I only saw this later when I was trying to build the code, so make sure that the names are exactly the same. When this event handler executes, it must send a new keyPressed message. And if you can recall, the keyPressed message contains a public member of type keyEventArguments. So we must assign that member the current event. Go to the Models folder, add a new class and call it ObjectInGame. This class represents a specific object that will be present in the canvas when the game is running. This could be a part of the snake's body or the food which the snake is going to be eating. In the class, add a member called type, which will tell us what type of object the class is, i.e. snake or food. Direction will indicate which way the snake is moving. Add the object's X and Y coordinates on the canvas. A rectangle for the snake's body and an ellipse for the food. Create a constructor which takes type, direction, and coordinates of the object as arguments. We'll make the color of the snake red and white for the food. Notice that the object is given the size of 10 by 10 pixels. Go back to the main view model and create a list of type object in game. Let's call this list objects in game. Create a variable of type random and call it random numbers. We will use this variable to create random coordinates for the food which the snake will be eating. Meaning whenever the snake eats the food must reappear somewhere else in a random position. Create a flag and call it incorrect food position. This flag will be very useful when we start generating the food's position randomly. For example, we don't want the food's new position to be where the snake is. More on this a bit later. Create another flag called game over to indicate the end of the game. Let's also create a thread and call it thread 1. Our game will be running in this thread. In our constructor, let's initialize our two flags. True for incorrect food position and false for game over. Create new instances for random number in the list objects in game. Add the first object to the list. Remember, the objects in game constructor requires type, direction, and coordinates as arguments. The first object in the list will be of type food. We will set the direction to null because the food doesn't move. Let's give it an initial position of 50 and 200. The second object in the list will be the head of the snake. So the type will be snake body, and let's give it a direction of right and coordinates 100 and 10. We'll add two more snake body objects, creating a snake that has a total of 3 rectangles. Now let's create a function called update game field. When this function is called, it will clear the canvas and update it with the new position of the snake. Let's loop through the object in game list. If the current object in the list is of type snake body, we will set the object's rectangle and its coordinates and add it to the game field canvas. Remember that the game field canvas is bound to the main Windows XAML code. Meaning when we update the game field, the canvas on the user interface will update. Next, we will check if the current object in the list is of type food. If it is, we will set its ellipse, coordinates, and add it to the game field canvas. Go back to the constructor and call the update game field function. At this point, I realized that the canvas was not updating. I fixed this problem by giving the game field variable get and set properties. Now when I run the program, we can see the snake and the food. Create a function and call it run the game. This function will execute when the game starts. Inside the function, create a while loop that will run for as long as the game is not over. Go back to the constructor and create a new instance for thread 1. Inside the new thread brackets, notice this lambda expression that consists of the function run the game. What this means is that when thread 1 starts running, the run the game function will execute. In other words, the run the game function is executing on a separate thread called thread 1. Next, we will start thread 1. Create a function and call it move snake. As the name suggests, this function will be responsible for moving the snake. To achieve this, let's look closely at the objects in game list. Object 0 in the list is the food. Object 1 is the head of the snake. And object 3 is the tail of the snake. The total size of the list is 4. Each object in the list has its own XY coordinate and direction. We'll start moving the snake from the tail. To do this, we will make object 3's coordinate and direction equal to that of object 2. Then we'll make object 2's XY coordinate and direction equal to that of object 1. Then we will move object 1, which is the head of the snake, based on what its current direction is. Create a for loop that will loop from the back of the list, i.e. from object 3 to object 1. Note that the loop doesn't go all the way to object 0. because object 0 is not part of the snake. It's the snake's food. Inside the loop, assign the new coordinates and directions like I just explained. When the for loop is done, move the head of the snake based on its current direction. For right and left direction, the snake will move on the x-axis, either forward or backwards. And for up and down, the movement will be on the y-axis. Notice that the snake moves in steps of 10 pixels, which is the size of each rectangle on the snake's body. Go to the while loop inside the run the game function and call a dispatcher for the game field canvas. Doing this will allow you to make modifications to the user interface in a different thread. Remember, the function run the game is executing in a different thread called thread 1. We will first call the move snake function and then update the game function. Before repeating the while loop, let the thread sleep for 1000 milliseconds, which is 1 second. You can change this value based on what speed you want the snake to move. Now when I run the game, you can see the snake moving at a speed of 1 second intervals. I'm going to change the sleep time to 100 milliseconds for a faster speed. Create a function and call it change snake direction. This function must receive an argument of type key pressed message. Check to see if the up key was pressed and also make sure that the snake's current direction is not down. This is to make sure that the snake doesn't move in reverse. If both of these conditions are true, change the head of the snake's direction to up. Do the same for the down, right, and left keys. Go back to the constructor and register to the key pressed message and include the change snake direction function. Doing this will make sure that this function executes every time a key pressed message is sent. Now when I run the program, I can change the direction of the snake by using the up, down, left, or right key. But as you can see, the snake is not able to eat the food yet. So let's add that feature. Create a function and call it increase snake length. Inside the function, declare a string variable named direction and assign it the current direction of the head of the snake. Check to see if the coordinates of the head of the snake is similar to the coordinate of the food. If this condition is true, it means that the snake has eaten the food. Inside the if statement, insert a new object in the objects in game list. Insert this object in position 1, making it the new head of the snake, and give it the same coordinates as the food. Create another function and call it generate new food position. Declare two integers x and y. Create a while loop that will execute for as long as the incorrect food position flag is true. Give the x and y integers a random number between 10 and 270. Set the incorrect food position to false. Check to see if the randomly generated xy coordinate is the same as any part of the snake's body. If this is true, set the incorrect food position flag to true. Outside the while loop, give object 0 the new randomly generated xy coordinates. Remember, object 0 in the list represents the food. Set the incorrect food position flag back to true again. Go back to the increase snake length function. Inside the if statement, call the generate new food position function. In the run the game function, call the increase snake length function. When we run the program now, we can see that the snake can eat the food and also grow. However, the snake cannot yet collide into itself, and this shouldn't be the case. The snake can also go outside the canvas. To fix this, let's create a new function and call it check snake collision. The function will loop from object 2 in the list all the way to the tail of the snake. Inside the loop, check to see if the coordinate of the head of the snake is similar to that of any part of the snake's body. If this is true, it means that the snake has collided with itself and the game must terminate. Outside the for loop, check to see if the coordinate of the head of the snake has exceeded the borders of the game's canvas. If this is true, the game must end. Call the check snake collision function in the run the game function. Outside the while loop, call a dispatcher again for the game field canvas and display a message box with the message game over. Then send a close main window message. Running the program now, we can see that whenever the snake bumps into the borders, a game over message pops up. And after clicking OK, the game window closes. Our game is now complete and ready to be played. And that's it for this video. Thank you for watching. Like, subscribe, and keep coding.